Okay, so welcome to this video on kinetics. So today I'm going to go through rate laws and determining the overall reaction rate law. So first of all, I'll draw up our question. Okay, so today we're going to work out how to determine the rate. So the orders of the rate law. So the value M for NH4 plus and N for NO2 minus. Now when we're trying to work out how the rate or the initial rate is changing for the reaction, we want to hold one of the reagents constant, double the other one, and see how doubling that reagent changes the overall rate. So if we look at our data set here, we have NO2 minus, and we've got NH4, and we've got our rates, and then we have each experiment. Okay, so we've got two different experiments. We've changed the initial concentrations and we've determined the rate of those initial concentrations. So if we want to work out NH4 plus, we want to make sure that the NO2 minus is not changing. So if we choose experiment 2 and 3, we can see that the 0.1 molar is the same. So it's not changing in those experiments. And if we look at the NH4 plus, we can see that there is a doubling. So we've doubled the concentration of the NH4 plus, and we have a look here at that rate there, and that is also doubling. So when this is going up by 2, and this is going up by 2, that indicates that it's a first order reaction. So M here would equal 1. Now, if we're doubling our concentration, holding the other one the same, and nothing's happening to our rate, then it's 0 order. If we're doubling, keeping this constant, remember, and this is going up by a factor of 4, then it's a second order. So we've done NH4 plus, so how about we have a go at NO2 minus? So now we want to keep the NH4 plus the same and double the NO2 minus. So these ones here, are the same, okay? And then if we have a look here, we're going from 0.05 to 0.1. So we're doubling the concentration of NO2 minus and not changing the concentration of NH4 plus. And if we look at our rate there, we're going from 1.37 to 2.7. So that is going up by a factor of 2 again. So we're doubling. So when we've got a double and a double, then we've got our N equaling 1 as well. Now, these experiments might not be in exactly the right order for it to work out like this. You might need to pick experiment 1 and 3, for example, to try and keep something constant and doubling the other one. Or we might have the 3 being half the amount of the 1, so we need to work between 3 and 1 in the reverse order. But as long as you sort through all your different sets of experiments and you find the ones where you can hold one steady and double and then see what's happening to the rate, then you can work out the 0 first or second order rates. So in order to finish this question here, you can solve for K. So it's a matter of plugging in any one of these experiments. So we might choose experiment 1 and put the values into the expression here. So we've got that equals K that we're trying to find. The rate is 1.37 times 10 to the minus 7. The concentration of NH4 is 0.1, and the order is first. And then the concentration NO2 minus is 0.5 to the power of 1 because it's first order. So let me write the M equals 1. N equals So if you rearrange this, so to rearrange you would go K equals 1.37 times 10 to the negative 7 divided by 0.1 times 0.05. So bring that around to the bottom. And you should get out 2.74 by 10 to the negative 5. So then we can write out our whole rate law. So the whole rate law there would be the rate equals 2.74 by 10 to the minus 5 NH4 plus and NO2 minus. Okay, well, let's have a go at another example. Okay, so with this example here, we want to determine the overall rate law using the concentration of the initial NoCl2, so these will be in moles per litre, and the initial rate of those reactions. So the rates, the units for those ones are moles per second. Okay, and these are in molar, big M, so moles per litre. Now, what we want to do is we want to look at NO first. So we're going to be doubling the concentration of NO, holding the Cl2 constant while we're doubling them. So we can see that the 0.0250 is double of the 0.0125. So we've got two options. This is going to be our doubled one. Now, when we're choosing between these two options, we want to look at the Cl2 and we want to make sure it's staying constant. So we've got 0.0255, 0.0510, 0.0255. So this one and this one is the same. So they're going to be the experiments that we choose. And we're doubling, so by 2, and having a look here at our initial rate concentrations. So it's not doubling. If it was doubling, it would be going up to 4. So it won't be first order. It's not changing, so it's not the same. So it's not 0 order. And the other one would be second order. So that's going up by a factor of 4. And you can see that is, so it's going up by a factor of 4. So this one, NO, would be to the power of 2, because it'll be second order. Okay, so we can start writing our expression now. So let's work out Cl2. So now we want to keep the NO constant, and we've got a doubling here. So these ones are the constant ones. So we're doubling. And having a look at that rate there, we're going from 2 to 4. So we've got a doubling there. So holding one set steady, doubling the one we're interested in, looking at the rate, and we've got a doubling. So that's telling me that Cl2 is first order. So now we can then go and work out the rate constant for this overall reaction. So in order to do the next step, we would be working out the K. Before we do that, we can talk about the overall rate order. So to work out the overall rate order, it's the M plus the N, giving your overall rate order. So the order of your first one would be your M, and your order of your second one would be your N. So it'll be 2 plus 1. So overall, it'll be third order for the reaction. So second order with respect to NO, first order with respect to Cl2, and overall the reaction is considered third order. So now we can plug in for K. So choosing any of your experiments, I tend to always just choose the first one because it's the first one on the list. So let's choose the first one. Let's choose the first one. So the rate, 2.27 by 10 to the negative 5. K is what we're trying to find out. NO would be 0.0125 to the power of 2. And Cl2 is 0.0255 to the power of 1. So then you can put it into your calculator. Now I've got a bit more space now, so I'll rearrange it for you. So to get K by itself, we want to bring this whole section here to the other side. So this is a multiply, so we're going to divide both sides by it. So 2.27 by 10 to the minus 5 divided by 0.0125 to the power of 2 multiplied by 0.0255 to the power of 1. We'll leave it drawn in, and that will give you K. So I'll put that into my calculator and we'll see what K comes out to be. So K therefore equals 5.7. So I can rewrite the expression. So the rate equals 5.7 times your NO2, power of 2, Cl2 to the power of 1. Okay, so now anytime I know the concentration of these two, I can work out the rate for that given time.